Canvas training. Learn.
Today we'll see in depth of what are the DevOps toolset which we do have in our curriculum, which we are going to study in our upcoming sessions. Let's start with our session for today. Okay, so today we are going to talk about DevOps tools, wherein we'll speak about Linux as operating system, because that is very much needed, guys. Only Windows won't help, because almost all the distributions, it's like couple of distributions, couple of platforms which I've seen are Windows. Mostly distributions are of Linux. It is either Ubuntu, it is either CentOS, it is either Rail. So mostly it sits on, or the DevOps tool sits on Linux distribution itself. And some of the tools are looking for Linux as a kind of background, as a kind of operating system over which it can install. So understanding Linux, having kind of basic idea about Linux is very much important. We'll understand some concepts about scripting. We are not going to get much in depth in scripting part. We'll have more classes on Linux. We won't go much in depth in scripting part. We'll know only the basics about scripting. Other than that, we'll talk about the build tool, which is Maven. We'll talk about cloud platforms, which we are going to cover in our sessions. We'll talk about container technologies and other technologies, other tools which is going to support container technologies. We'll also talk about the configuration management tools. What are the tools we are going to cover? Why configuration management tool is required? So let's start, guys. Okay, so let's talk about Linux. I'm sure a couple of the candidates in the session, they are already familiar with Linux. A kind of basic idea about Linux everybody have. I'll just brush up all those ideas and kind of fine tune it, because in upcoming sessions we are going to use Linux as a platform where we do lots of things, all the practicals. Today I have a thought. I have brought up one of the Linux box with me, which is CentOS. Herein I'll try to show some of the commands, some of the basic commands in Linux. Okay, I'll try to show some of the directory structure, inverted directory structure, which Linux follow. I'll try to show all the basic directories or basic folders which is available there in Linux under its forward slash distribution, forward slash partition. We'll understand that. Okay. So let's understand, guys, first what Linux is. What Linux is. Linux or Unix operating system, whatever it is, what are the component of OS? This will be a part of our learning curriculum, wherein we'll get to know how internals of OS works, how internals of any of the operating system of Linux distribution works. Guys, let me tell you, it's different from how we work in graphical mode, GUI mode. In this session, learning curve will be more about learning new commands. Anything guys, what we do in Windows, we'll try to do in Linux system. In Windows, what we do? We open a system, we double click and a folder opens. We have certain set of commands which allows any of the folder to open. We'll learn all those commands, how to open a folder, how to do some of the modifications under that folder, how to delete, how to add any new file, any new directory, and a new folder under a folder, a kind of subfolder. We'll see that. Whatever we are doing on Linux system, we'll do it on a black screen where we get CLI command prompt. What next we are going to learn is, we are going to learn various services, utilities, important files and directories which is included in Linux. We will see different utilities in Linux. In Windows, guys, we basically can either share or show data by the text pad or notepad editors. Similarly, we have some editors, couple of editors in Linux also. We will get to know about that in our upcoming sessions. Okay. Other than this, we have some of the commands which will help us to understand how we can quickly modify any of the data which is present there in our editors. There are a couple of editors like gedit, vi editors in Linux. We'll learn about some of the commands which can help us to understand how we can quickly modify our, our data which is present there in our Linux operating system, Linux machine. Also, along with that, what we'll do is since ages we are working on Windows, so we are very familiar with Windows. So what my plan will be to keep comparing things with Windows. Understanding will be much easy. Like, we see in Windows, right? What is C drive? What is E drive? We know about that. What is C drive? What is E drive? And Windows. Similarly, we'll have some partitions, some drives, and Linux also. What we do basically in Windows, we open a task manager, and in task manager, we see multiple front processes. We see resource consumptions and others. We see which task is utilizing how much percentage of my CPU, for how long it's running. Similarly, we have some sample commands in Linux also. By means of those, we can see various matrices. We'll learn how to see those matrices by bunch of commands. Also, along with that, we'll try to correlate with how it looks like in Windows in our upcoming sessions. We'll do that when we are talking about introduction to Linux. That will that will be important to understand, because when we say why Linux, because as I already said, most of the tools in DevOps is sitting on Linux. There is a reason that Linux is, of course, a freeware. It is an open source operating system. Anybody can install it. You can install it and you can work on it. We have different means by which we can install it. VMware is there. Multiple other softwares are there which allows us to create our own VM and install Linux, any of the Linux distribution. It can be Ubuntu, it can be Debian, it can be Rail, it can be SUSE, it can be CentOS to install and work upon it, right? Wherein in Windows, with the advancement, you have to purchase licenses and lots of things are there. It's not open source. Lots of restrictions are there in Windows, wherein Linux allows us, gives us that flexibility so that anybody can install it, learn it, and work upon it. Other than that, let me tell you guys, once you get familiar with Linux commands, you won't feel even to work on Windows. Because it's always time consuming. Even though we do not feel it now, it's always time consuming to move mouse, take it to one corner of screen to another corner. It's time consuming. When you start working on CLI, when you start only using your keypad, it actually will make you understand how much time we waste when we use mouse or some other means of transmission of commands. So I want you to be familiar with all those commands, which will make things much easier for you, which will help you to understand and which will help you to achieve whatever you want to achieve in faster way. That we'll learn in our upcoming sessions, and that we are going to learn when we are talking about Linux. Other than that, we'll also understand what partitions are. Like the similar way we do have C drive and D drive in Windows, we'll also have similar kind of partitions in Linux also. We'll learn what those partitions are. For example, as I've shown in the screen, this is a partition. This is a partition, guys. Other than that, we have multiple partitions available. See, dev, dev shm, slash. These all are partitions. We have separate folders for that dev, which allows us to see how many partitions we can create. We can get into that. If we are not familiar with these commands, not worry about this. So, because we are going to learn all these commands in our upcoming sessions. This dev, it gives me all the devices which is created. It gives me the information of disk. It gives me the information of file systems, which is already created on my machine, right? It gives me the various VCAs which I have created on my machines. We learn one by one each of the things what it is in our upcoming sessions. Along with this, we learn about multiple boot processes. We'll get to know what boot processes are. We'll get to know what boot is. Here, as you can see, here we have certain files, which gives us the details information about how my system boots. We'll get to know about all the stages that that passes through when we basically try to boot a machine. You would have noticed it when you, even in Windows also, When you hit power button or when you want to start your machine, it goes through various stages. It stops somewhere and it tries to load the, the operating system from there. Once it's operated, even though the, the, some cursor rotates on screen and it lands to login page after a certain point of time. Certain stages passes on, which we do not notice even, which is not even visible to us at times, especially in Windows. It is not even visible to us. But when we jump into Linux, we'll get to know what are the stages which passes on from the moment we power on our machine till we see a well-settled GUI or CLI screen or login screen. We'll see that. As I said, we usually do not notice or we do not see that, but understanding those processes will be essential. We'll see that in our upcoming sessions. Other than this, we'll talk about the very basic thing in Linux, which is the Linux architecture. Of course, Linux architecture, boot process, kernel information will be very much important. Installation part, what I'll say is I can give you the link. Yesterday, it was not possible to upload that for some technical issues. Now, I'll try to upload it today. As I said, I can give 2 ways. Either I can upload there on my Google Drive. Other than that, there are means by which we can upload there on our web page, on our home page also. I'll try to speak with Genbest management team and try to make some way how we can achieve that. The installation part, you have to take care. Once you install, you'll get to know lots of things actually following the documents which we upload there. Other than that, what we need to know about Linux is the architecture of Linux. Guys, let me tell you the kind of high-level overview of Linux architecture today. Anyways, we are going to discuss it in much detail when we'll talk about Linux, when we are going through Linux sessions. But I'll give you a high-level overview today. So as I said, Linux is a free and open source operating system. There are other features which makes Linux a kind of very demanding thing in market. The portability feature of Linux. Linux is portable. It's very easy to be migrated from one machine to another machine. Multi-user logins are applicable in Linux platform. For sure, it is there in Windows also, but there are certain restrictions and limits in Windows. We do not have any such limits here in Linux. If you go here, you'll get to know. Here, we have, say, multiple users. I have created 3 users here. On this machine itself, I can see 3 users are created. Okay, one is cloud user, SSM user, and third is I have created one user on my name. So these kind of users you created and n counts. It doesn't have any limits there in Linux. That makes Linux different from any other platforms. So the basic thing which we learn, which we see there in Linux is the core part in Linux is the Linux kernel. The central part, which we also say as core part here, is Linux. Now guys, let me tell you, it was the Linux which was developed initially. Nothing other than kernel was developed initially. Also, we can say kernel as heart of Linux operating system. Linux is the component, guys, which is responsible for a lot of things that happens there in Linux. Kernel is basically the component which drives lots of things which happens there in Linux case. It takes care of almost all the things at lower level. There are some other programs, there are some other shells which works along with kernel, which gives us the kind of view which we want to have. Like here, I have certain kernel, see VM lineage. It gives me the boot system. It gives me the kernel details, grub. Can you see the left side of my screen, grub? It gives me the details. It gives me my kernel details. It helps me, it helps my kernel to boot up when I'm powering on my machine. VM lineage, grub. These details, these components helps me. We'll learn about these grubs. I won't go much into grub. But yes, I'll be discussing kernel now and then when we are talking about Linux. We'll talk about BIOS, which is basic input output systems. When we are talking about Linux, we'll get a kind of overview about grub. As I said, grub stands for something which is called Grand Unified Bootloader. It loads the kernel into memory and passes control to it so that we can utilize it. We can have all our previous data saved there in our machine by using grub technology, by using grub component itself. And kernel, of course, it resides on RAM until system is shut down. It initiates the init process whenever we are trying to boot up the Linux machine. Kernel, as I said, guys, is very important component then in Linux. Coming to scripting, as I said, I won't be going much into scripting. So in scripting, my view is to understand mostly about what different kind of shells we have in Linux. We have different kind of shells available in Linux, which is, some of those are bash, csh, tcsh, and ksh. Bash is nothing but it's called as born again shell. CSH is called she shell. TCH is called Linux C shell. KSH is called corn shell. We'll get to know about these all shells when we are going in our upcoming sessions. We'll be mainly focusing on bash because most of the time when we log in and we work in Linux, what we do is we work on bash shell itself. That is very user friendly. It gives us lots of features. Maybe some of the features we are going to see in our upcoming sessions. Okay. So what we will learn when we are talking about bash is we will learn about the inverted directory structure of Linux. What we will see is, we'll see here. Say now, I am at the basic root directory here. Now, what my present directory is, do not worry about these commands, what I'm typing. We'll learn about each of the command. When I issue a command, which displays what is my present working directory, which prints my working directory, it is what? It is /. This is the topmost partition in Linux. This comes first. Anything resides after that. You can see here lots of directories are there. Lots of folders are there. Bin, boot, dev, etc, home, lib, lib64, media. Each of the directory is having its own role. Each of the directory saves something within it. To name a few, root. Root is a directory which you will get only when you are logging in as a root user. As you can see here, I am logged in as a root user. So we'll get into this. You will get to know about details about root. Now here you can see some of the RPNs, some of the swap partitions which is available. Anybody who's trying to install VM there in their machine, they have to create swap for them. What swap is, we'll get to know when we are going through in our conversations. Okay. So we'll get to know what each command does. Like I'm issuing a command ls. What this command does. Let me go to the root directory. Now if I issue command ls, what this ls is, there are separate manuals which is saved there. See the manual for ls, it tells me what ls is. It lists the directory contents. But from where this man is pulled, this should be saved there, somewhere there on my machine, right? So that we will see how to fetch. For example, in case of ls, if I issue this command, where is ls? Then here you see the entire manual for this ls is saved here at this location, which is user share man page. This is the location from where when I'm issuing a command man ls, it's getting all the outputs. It's throwing me the output from there. We'll learn about that. All right. We'll learn about some other directories. We'll get to know some of the we'll have the knowledge of boot directory, what boot directory is, what it saves within it. As we have already seen in our previous command output, it gives us the output about VM lineage. It gives us the output about grub details. We'll get to know about it. We'll get to know about dev details, what dev is. what are the devices it contains. We'll have that idea. Other than this, you can see there are multiple directories. Directories are nothing but, guys, it's like the folders which we see there in our Windows. We'll get to know about these directories. Guys, initially what I'll do is I'll try to compare the notations which we use there in Windows with the notation which we use here in Linux. For example, C drive there is called partition in Linux. We have the concept of folders in Windows. Folder is called directories in Linux. Files are same. So I'll try to compare both the notations which is there in Windows and which we use there in Linux initially. Later on, when you guys will be familiar, we'll talk only on terms of Linux notation. Right? So this is what we are going to learn when we are talking about scripting. Other than that, I'll give you idea about lots of basic commands which we do have in Linux on Linux machine. I'll tell you what this hash prompt mean. There are some other prompts like, say, if I'm logging in with my ID, there are dollar prompt. What is the difference in between hash prompt and dollar prompt? We'll see that. We'll understand that very nicely when we are discussing it, when you're talking about this. Several commands, few of the commands which I've issued, which is pwd, other many commands we're going to talk there when we are talking about Linux in details in our upcoming sessions. We'll learn how to create folders. It's very easy to create folder in a Windows machine, right? Just right click and hit on folder, it gets created. But you know, right clicking your mouse and hitting on folder takes time. But if you are familiar with certain commands, it is much easy here. For example, I want to create a folder here. Okay, it needs certain permissions. So I am a root user now. I can easily create something. If you are a root user and if you want to create something, see, it's like a matter of time you created it. Says you have created one folder for yourself, which is test1. Okay. So it's very easy to create it here than what we do, how we create there in Windows. It will be much faster when you are learning how to work on CLI. So we'll learn how to create folders here. We'll learn how to remove or delete any folder here. We'll learn how to copy a file from one folder to another folder by using Linux commands when we are talking about scripting, right? We'll learn about many of the shortcut commands, how to display the content of a file. For example, if I'm writing something, if I'm creating something, that I'm writing something in a file, please do not worry what VI is. We are going to learn what VI is. If I'm writing something in this VI, okay, if I'm writing something in a VI, how to display it without opening a file, we'll learn about it. Okay. Okay. So we'll learn how to open it, how to open it without, how to read it without even opening it. We'll learn all these contents when we are talking about when we are going through our Linux topics, when we are going through our Linux sessions. I'm just giving you a kind of visibility how it looks like when we are going to work. This is how it will look like. For sure, we are going to see these details when we are going through our sessions, our upcoming sessions. So these were certain things which we are going to cover in scripting part. Linux, we have seen scripting, we are going to cover these things. Other than that, the tool which we are going to see will be a build tool. We'll get to know about build tool. I mean, let's talk about what first build tools are, what it requires to function properly. We'll get to know about Maven also. We'll get to know much in depth about Maven when we're talking about build tools, the category of build tools. Maven is a build tool. Now, guys, if we take a build tool, I mean, doesn't matter if it's Maven or Ant or Gradle or any fourth one. Any of the build tool to function properly, it requires something which is called configuration file. Okay. Now, what is mentioned there in configuration file? It is the configuration file which is very much specific for a project. Say if I'm working on 10 projects, I need to have 10 different configuration files for 10 projects. This configuration file tells me what we want to achieve, when to call, what we have to tell to the tool. The tool can be either Maven or Ant or Gradle or any build tool which we're using. But what we have to tell to that tool to function, that that part resides with, that part stays with configuration file. What to do? Now, say if I have a code and if I want to build that code, that requires certain resources, certain compiler, certain other tool, right? Which can compile the code, compile the source code which I do have present in my workspace, which I do have present in my working directory. I need to have that tool somewhere. That tool information should sit, right? So that it picks up automatically when I call the build to Maven in this case. When I call Maven, it should automatically pick up the details of my tool, details of my source code, the location of my source code, the location of my tool. All the details are fed in somewhere. That somewhere is called configuration file in a build tool. As I said, this configuration file is specific to any of the project, and this configuration file has to be present there for any of the build tool. Today you are learning Maven. Tomorrow, even though if you learn Gradle or End, configuration file is mandatory there also. All the details, guys, will be specific to configuration file for a project. For every project, we'll have configuration file through which we define all the details about the project to Maven or any build tool in that half, and that, keeping it on generic note. In Maven, how it goes, guys, let me tell you. For the project which we are working upon, we'll have a configuration file. That file is called pom.xml. That file, the name of that file is pom.xml. Pom file we call. Okay. The pom is nothing but project object model. That pom file is called project object model. Now, the name of the file will be that it won't be any separate name, any distinct name in any of the configuration file. The name of the file will be precisely mentioned as pom.xml. We'll talk about what pom.xml is, how to write that pom.xml, what are the components of pom.xml when we are discussing about our topics. Assume that, guys, we have a project. The project which we create, and pom file is present there for that project. In that pom file, all the details of the project are present. Now, pom file should be in the same workspace, same working directory where other raw files related to the projects are kept. It could be source code also. Pom file will consist of all the goals of a project. Now, what goals are? We'll get to know about what goals are when we are discussing about Maven, when we're talking about Maven. To give you a high-level overview, anything which we specify to Maven, that Maven will do something. What we want to achieve with Maven is called goal, where what goals will do? Goals will invoke plugin, and this plugin will call a task. Guys, do not get worried if I'm talking about some terms which is not familiar to you. We'll discuss about these terms much in depth when we are discussing about these topics. It's just a high-level overview of what we are going to discuss. So guys, when we call Maven, what it does is it actually try to read file which is called pom.xml, which is available there in current directory of execution. When we try to call Maven, we go inside the workspace in which we will have a specific configuration file. It will try to read the details which is mentioned there in pom.xml. Those details could be anything, guys. Those details could be the location where my source code resides. Those details could be the location where the tool information resides which is required to compile my source code or to perform any of the activity on my source code. That could be anything. So what basically POM file, to summarize, what basically POM file will contain? POM file will contain list of sources, the sources on which we need to perform some action like compilation, as I said, like compilation, deletion, creating a package, That package could be in war, jar, or ER format, which we have seen yesterday. Other things which it will have is the list of resources which is required to get worked upon on this file. This can be any of the plugin or dependency. Plugin is nothing but these are certain resources which is required for 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 any operation which we want to achieve, which you want to work upon on a file. It could be compilation, deletion. We need certain tool. Those tools are pulled in by using certain plugins. We'll get to know about that. So, say for example, if I say perform compilation, what it will do is what Maven will do is it will search for resources or tools which is needed for compilation. It will also search for files which has to be compiled and few other components from configuration file. Herein we learn about the architecture of Maven. What basically the architecture of Maven. At the heart of Maven, it resides form.xml, which is the configuration file. As I already said, configuration file looks for the resources and sources also on which the activity has to be performed, and also the tool which is required to perform that activity. Now, a question should come in the mind where exactly it looks for. Everything cannot be present on my laptop, on my desktop. There should be some location, some repository from where it can go and pull those details. In Maven, we usually maintain two kind of repositories. One is local repositories and another is a remote repositories. Local repository is local to my machine, whereas a remote repository sits on web. We'll get to know more about what local repository and remote repository is, where it is defined, how it is defined when we are learning about Maven base. We'll talk about Maven much in detail. We'll learn how to build a project, what are the default life cycles of Maven. Default life cycles, for example, is to generate and to obtain resources or sources, compilation, testing, packaging, installation, deployment. There are certain other life cycles also, which is clean and site life cycle. We'll get to know about those details also. When the package is formed, how the package looks like, whether it is in jar format, war format, ER format, everything is defined there in the Maven form file itself. We'll get to know, we'll see how it looks like. Okay. Other than this, Maven also follows certain directory structure guides. We'll get to know how it follows those directory structure. We'll understand that how directory structure looks like. For example, here in this slide, you can see we have three different plugins. One plugin is for .jar, another plugin is for Surefire. Surefire is nothing but, guys, it's a plugin which allows us to perform unit tests. It gives us a report in two formats basically, in .txt and .xml. We'll see how Surefire plugin works. Maybe we'll use this also when we're talking Jenkins as a topic. Here's some of the plugin like release. This helps us in releasing our project, our products. We'll get to know about this more in depth. Coming on to our next slide, which is introduction to cloud. Herein, what, because we cannot cover up entire things in cloud, because if I'll cover up entire things in cloud, the cloud itself will take 10 to 12 sessions, even more than that. So I won't be covering entire thing in cloud. We'll be touching only those topics which is very much related to DevOps, which is needed for as a DevOps perspective. I'll be talking about cloud component. We'll talk about cloud. What are the different deployment models in cloud? We'll be circulating around AWS as a vendor. I'll try to give a comparison in between AWS, Azure, GCP, a kind of different services which AWS provides, Azure provides, GCP provides, so that you'll have an overall idea how AWS is different from Azure or GCP. So these kind of topics which we'll be covering when we are going through cloud, when we are covering up cloud. Coming onto the slide, we'll get to know what cloud computing is. To give you an example, guys, to give you an example, what cloud computing does, it ensures the availability of IT resources of our choice. Those resources could be network resource, servers, and these all resources are provided by the cloud vendor on a demand basis. That demand basis can be on the basis of cost. You pay whatever you are consuming, and the services are made available on the web. So it doesn't matter which geographical location you are, you can easily access services which is provided by the cloud vendor. That is made accessible by means of cloud. Essentially, guys, it is the responsibility of cloud provider to provide these services wherein customer, say you, me, and other customers who signs up for cloud, what they have to do is they should know how to properly utilize it. For example, just let me give an example here. For example, say if you are say Amazon or eBay and the traffic on the website of Amazon or eBay goes high on a particular day, it increases exponentially. Then what happens basically in a traditional environment, handling these situations is complex, wherein we have limited storage resources or compute resources which is required for increased traffic on that particular moment, on that particular day. Scaling up of database services is very tough. But what happens with cloud environment is it is just a matter of minutes where we can scale up and scale down based on the need basis. If the traffic goes high, we'll scale up. If the traffic falls again, we can scale down. That can easily be achieved by using cloud computing. Okay, we'll get introduced to what cloud is, how cloud formed, why cloud is needed. For example, if I'm purchasing today 10 servers at my home, if I'm connecting it with web, will that be considered as a cloud? Can I say that I am made a cloud, purchasing 10 servers, connecting it to web, and I start giving services to my clients? Can I say that it is a cloud? No. Cloud should meet certain criteria so that it can be called as a cloud. Certain attributes it needs to follow. Those attributes, as we have already seen in our previous slides, it's like on-demand self-service. Whenever I require something, today a traffic went high, I need to have more services, more compute or storage resources. I can get that. On-demand self-service. It should have it should have uninterrupted access on web. There should be something which is called measured services. What I basically mean by measured services is I pay whatever I use. Those kind of concepts, attributes are required for any infrastructure to be called as cloud. That we will know, that we'll see when we are getting into clouds. Not to that deep extent, but whatever it's required on DevOps perspective, we'll see that. Okay. As I said, cloud is required on on-demand basis. Other than that, we will see what are the different kind of cloud computing service models. That also we'll see. To name a few, we have on-premise, IaaS, which is infrastructure as a service, PaaS, which is platform as a service, and SaaS, which is software as a service. Why it's called infrastructure as a service or PaaS or SaaS, we'll get to know about it. When we are talking about as IaaS, PaaS, and SaaS, we'll understand what are the services which is managed, what are the components which is managed by vendor, what are the components which, as a customer, we have to manage. We'll see that half also. We'll talk about various cloud computing deployment models. If my cloud is public, if it is private, if it is hybrid, if it is community, what are the differences in between public, private, hybrid, cloud, and community? We'll understand that. We'll see that. Other than that, we'll also talk about regions and availability zones. What regions are, what availability zones are, why it's termed as availability zones, how many availability zones can be maintained in a particular region. We'll see that. What is edge location? A kind of terminology which is a caching concept wherein we have the concept of cloud front service. We'll see that when we're talking about AWS. Right. So therein we'll understand about these all topics. Okay. We'll also see the advantages and disadvantages. Advantages of cloud, disadvantages before cloud. Why why companies started using cloud? We'll see that. We'll see that much proper. Okay. Let's move on to our next tool set which we are going to cover. Containerization technology as a tool set there. wherein we'll talk about Kubernetes. We'll understand what Docker is, what Kubernetes is, and much deep. Okay. I want to start. I want to start explaining about Docker with one simple example, with one simple use case. Think about a company. It outsources one of the application on gaming side, which he wants to publish to all its clients. So what happens basically? I being a company owner, I take the project, I start working, I allocate some of my engineers to work on the gaming app. They design gaming app, they write code for gaming app, and now gaming app is ready. The prerequisites when the gaming app is created by my engineers, say for example, just take a scenario. It requires Java. It requires Ubuntu as an operating system. It requires some web server. For example, Tomcat. It's Apache Tomcat. It's a web server. So the gaming app to run properly, it has certain prerequisites. Those prerequisites are Java, say version 8.0, Ubuntu, Tomcat version 9. But that version, these all dependencies were there when my engineers were creating it. It's not important. It's not necessary that same softwares or same packages will be present there with my clients also. There is challenge there. There is problem there. So now when my engineers have written a code for that, they said, boss, we are all set. We are good to pass on this to our clients. And we have passed on this to our clients. We said that delivery complete. Now it came that time when we are providing support to it. Client says that they are not able to access it. We 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 investigated, we did troubleshoot, and we found that they do not their infrastructure do not meet the prerequisites. What we should do there? Should I lose the client? Can I lose the client? Can I afford to do that? No, I cannot afford to do that. So there are certain means by which we can achieve that. There are certain means. One of the solution is like a traditional method which we used to follow, decades ago. We go to client location, install all the infrastructure. Actually, we used to do this. I have set up certain network infrastructure to my clients. We used to go there. We used to get pass on to number of passes and number of security restrictions. Post that, we used to go to client locations. We used to install all the infrastructure and prerequisites which were needed for clients. But let me tell you guys, since I worked on these fields also, it is very hectic. How many clients we can go open like this? How many systems will install these prerequisites upon? It is very time consuming. It was very hectic. Travel was very hectic at those times. Okay. The second solution came. Second solution was by providing a virtual machine. What happens? We create a virtual machine. Rather, I'll say an image of virtual machine. Virtual machine could be of very heavy weight, but image of virtual machine is very light. It's nearly 2 GB also. And if you're installing VM, it can go to huge size. So I install, I create a image of VM. Now I put in all the components, all the prerequisites which is required for that application to run in that image. I install Java, which is 8.0 Java, maybe Ubuntu, Tomcat 9 in that image itself, and I pass on that image to my clients. Now my client can easily access gaming app by installing a VM which is setting on the VM image. They can easily do that. They can easily create that, right? So this was one of the solution. As time passed, we have now new technology which is called container. Container, these are like VMs, but there are certain differences in between containers and VMs, guys. Containers are lightweight. The best part of container is container are lightweight. Here, as you can see in my this slide, here what basically it requires. I have a host operating system. I have one operating system here, right? On top of operating system, I have one engine, something which is called engine. Guys, do not think about only Docker. We have multiple other vendors like LXC is there, LXD are there, OCI is there. Multiple other vendors are there other than Docker. Doesn't matter whatever vendor is. Docker, I mean, the container engine, it will have a container engine, whatever vendor it is. If it's Docker, if it's LXC, if it's LXD, if it's OCI, it should have to have one container engine. That container engine will sit on top of operating system. Fine. So when this container engine sits on top of operating system, it seems like some hypervisor in VM. Hypervisor is nothing but a virtualization software. Similarly, container engine is also like a virtualization software. Here in this slide, we talk about Docker engine. Docker engine is nothing but it is a container engine. It is nothing but a virtualization or containerization software. What we do basically in this is after we install Docker software, which brings in Docker engine or Docker daemon with it, we can run any number of containers. But containers, the main advantage with container is it won't have its own OS. It will have certain binaries or libraries only, which is required for a project to run, for my software to run. It will share host OS. All containers will sit, which will always share OS from my base operating system, from my host operating system guys. For example, let's take a use case here. If I'm talking about a Linux container, which is say a CentOS container or a Ubuntu container, it won't have Ubuntu OS installed in it. It won't have CentOS OS installed in it. Wherein, if I'm talking about a CentOS or a Ubuntu virtual machine, it has to has Ubuntu operating system or CentOS operating system installed in it. Let me show you one case here. See, I do have a virtual box with me. This is one of the virtual box which I do have. Now I turned it off. I have created four virtual boxes here. Two are Ubuntu, two are CentOS. CentOS different operating system. Now if I boot it, guys, see, it's like I have installed an operating system on top of my machine. I've given a base operating system which is 1 GB here. I have created it. I've installed operating system on top of my virtualization software, which I'm using here, which is VirtualBox in this case. But when we are talking about Docker engine, I need no need to have any operating system installed with me, as I don't have any OS. It is lightweight. It can be of size MBs also. The base memory you have seen just now, the base memory in my virtual machine is 1 GB. You can have one container itself of size such few MBs, say 200 MBs also. Some of the operating system like Debian, it goes to nearly 90 or 100 MBs also. We'll see that when we are talking about container as a topic. Let me give you one more use case, one more analogy of container, how container looks like. For example, if I'm moving from one location to another location, because container, whenever we talk about container, we think about cargoes, we think about something which is getting exported in those big ships, right? Something getting carried on those big ships. Something is contained in that container, right? So container in IT world is also same thing. It carries all the packages. For example, putting an analogy, I'm moving from one location to another location. I need to carry all my household commodities. I need to carry my vehicle, lots of things at my house I need to carry. Once that thing is put in a container, nobody in this universe can see what is there within the container unless it is opened, right? So integrity is maintained. What's there inside the container doesn't matter. It can be easily carried from one location to another location very easily, right? So my integrity is maintained. The safety of my stuffs are maintained. These are certain advantages of Docker. We'll talk about why Docker, why containerization, advantages of containerization when we are covering how it is different from VMs. We'll talk about that part also. Okay, so moving on to next topic, which will be configuration management. Introduction to configuration management tool. This will be very important to learn, guys. I'll start with an example. Developer wrote a code. That code requires Java to be present there on all the servers. That code requires Tomcat 9 to be present there on all the machines. Okay, so if my configuration management tool is not there, what an individual will do, what an administrator will do, he will go to individual machines. There are two means actually. The age old followed process was, the methodology was, he will go to individual servers. He'll try to install each of the packages. He'll install Java first, he'll install Tomcat next, and whatever the packages which is required for my application to function properly, he will install each of the component one after another. If it's one machine, if it's two machine, fine, well and good. Now tomorrow, if the client came and they say that in upcoming days, in upcoming months or years, I'm going to get a lot of traffic on our servers. I want you to add 200 more servers to our system. In that case, what an administrator will do? It's like, it's like a big task for any of the administrator to log into on 200 servers one by one individually and to install these packages, right? There should be some mechanism by means of which we can automatically do that. The next method is to write an infrastructure as a code. The infrastructure as a code, which we used to write initially was Perl and shell script, right? Was Perl and shell script. What we used to do there is like we used to write Perl and shell script, but that Perl or shell script which we used to write was not platform independent. I used to write code separately for Ubuntu machines, separately for Rail machines, separately for SUSE, separately for CentOS machines. There was no common platform for Perl or shell scripts to run. It was a problem. And for some reason, if say I am writing the script, tomorrow I left the organization, somebody who starts working on the script on the entire infrastructure once I leave, it it was a very bad time for that person to understand what I wrote in that script. Understanding Perl or shell script was not an easy task. That brought the need of configuration management tool. In our curriculum, we are going to talk about configuration tool management tool in much detail. We'll learn Ansible as a topic there, wherein we'll get to know about Ansible as a tool there. We'll understand all these components, how these components can be achieved. We'll start with the introduction to Ansible. We'll learn Ansible architecture. We'll set up Ansible in our environment. There are ad hoc commands in Ansible. There are playbooks in Ansible. There are certain roles in Ansible which are like predefined modules, predefined components. We'll learn about each of the topic, architecture, ad hoc commands, playbooks, rules, each of the topic one by one when we are covering. Okay, let me give you just an idea, kind of high-level overview what Ansible is. Ansible is nothing but it is a deployment automation tool, which traditionally, I mean, it's always important to remember that it traditionally uses push. It can use pull also. What pushes, what pull is, we'll get to know about it. So it is one automation tool which uses push approach to achieve its objective by managing all the servers, 200 servers, 300 servers, any number of servers which you do have through one single machine, which is achieved by running the Ansible configuration management tool. You'll see how it manages multiple tools. What my plan is to create one master machine, one which is like managing machine, and another maybe one or two machine which is managed machine. What my suggestion to you guys will also be to have at least 3 machines with you so that you can properly understand the distribution of flow, how the flow goes, how Ansible tries to reach each of the machine. You'll try to understand that. If you have more than 2 machines, if you're keeping 2 machines, then the picture won't be that clear. because one will be managing, another will be managed. So that flow won't be clear, right? To get a better understanding of the flow, it's important. It's always good to have more than two machines. My plan is to have three machines minimum so that we can use it, we can understand it nicely. We'll learn how to what is push approach, what is pull approach, how the push is managed. Yesterday we learned about Git, so how the code is pulled from Git, how it goes to Ansible, how that code, when it's packaged to jar or war format, it gets published, it gets provisioned to either container or bare metal server by using Ansible as a tool. We'll understand that. We will also compare Ansible with other tools. We will see we'll see what other tools are. We'll compare other Ansible with some other tools like Chef, Puppet, SaltStack, and we'll try to understand how Ansible is better than any other tool. Okay, let me tell you guys, Ansible is simple enough for any of the new user. If you have never used Ansible, I heard Morris was saying that when he saw Ansible playbook, it did not look that easy. So when we are going through the playbook section of Ansible, I'll show you how simple it is so that it can be learned very easily. And also it works at high enough level. It is simple and it works at high enough level so that it can get integrated with any other tool here in DevOps infrastructure, DevOps various stages to achieve DevOps, basic goal. We'll see that also. Yeah. Other than this, for sure, we are going to, as I said, we are going to learn about other components of Ansible. We'll learn about roles, architecture when we are going to Ansible as a topic there. We'll learn the entire how to use configuration management tool. Thank you all for joining. Tomorrow we are going to meet. We'll start our session on Linux. I hope I'm able to. Thank you everyone for joining in. Okay, thank you. Thank you everyone for joining in.
Jan Bass Training. Learn and grow.